Welcome to today's tutorial. In this quantitative method tutorial, I'll be focusing on how to construct the stem and leaf and how to calculate the extreme values and the quartiles. This is one of the questions that your examiner likes asking in your MBA quantitative methods. So let's take, for instance, the data which has been given here and see if we can construct the stem and leaf and also calculate the extreme values and the quartiles. Okay, so this is just under statistics. All right, given the following marks obtained by 9 students in quantitative methods test, 81, 85, 2, 79, 3, 81, 4, 89, 5, 73, 6, 57, 71, 8, and 76, 9. You are required to construct the stem and leaf. So let me demonstrate how you do the stem and leaf. The first thing is identify the lowest number. So in this case, the lowest number is 50 there. That's the lowest number. And then also identify the highest number. The highest number in this case is 89. All right. So we can safely say our stem and leaf will range from 50s to 80s. So how do I get to demonstrate that? So what I'll do is I'll just draw a line here. So you can see that's the line. And then I'll draw another line going down here. I shall call this side of the diagram I've drawn as stem, and then this other side I shall call it leaf. So these are the stems. The stems will tell us the way the numbers are moving. They are moving from the numbers are moving from 50s to 80s. So I'll put 5 here to represent the 50s. And then I'll put, do we have any numbers in the range of 60s? No. So I'll skip the 60s. Do we have any numbers in the range of 70s? Yes, we've got 73, 71, 70. Okay, so the next stem will be 70s. The next stem will be 70s. And then I have the numbers ranging in the 80s. I can see the 80s there. So the next stem will be 8 here to represent the 80s. So we've got numbers from the 50s represented by 5, from the 70s represented by 7, and from the 80s represented by 8. All right. So now from here, I'll check those which are ranging from the 50s. No. I'll just start order by order. I'll start with the first number. The first number is 80. So if it's 80 there, what I do on the 80s here, I'll simply bring the 0 here, meaning this 8 and that 0 makes the 8. The next number is 85 here. So I'll bring the 5 here, meaning that 8 and that 5, they're making 85. Okay, and then the next number is 79, meaning I need to bring a 9 here where there are 7s. Then the next number is 81. I need to bring a 1 here where there are 8s. Okay, then the next number is 89. I need to bring a 9 here to indicate 89. Then the next number is 73. I need to bring a 3 here to indicate 73. Then the next number is 50. I need to bring a 0 under the 5 is there to represent 50. The next number is 71. This one, I need to bring a 1 here to indicate 71. Then the next number is 76. I need to bring a 6 under the 70s here to have that. Now, what it is that this term and leaf is not arranged in order, so this is not the final answer. I need to copy this and arrange it in order. All right, so I need a line here. So if I'm arranging it in order, there's nothing to arrange under the 56. There's only 1 1. Then on the 70s, I'll start with the lowest number. The lowest number was a 1 here. So I'll start with a 1, and then followed by a 3, and then followed by 6, and then followed by 9. I'm getting them from here. So I'm just rearranging. Then on this one, the lowest number also was a 1. No, 0. And then a 1. And then a 5. And then a 9. Like that. Okay. So we have the arranged term and leaf, meaning you will have responded to the first question. The second question is to calculate the extreme values and the quartiles. So I'll begin with the quartiles. Quartiles, there is a quartile 1, Q1 is given by 1/4 multiplied by 1 plus n its value. Then like this, so it will be like that. Perfect, to be like that. That is quartile 1. So in this case, we will say 1/4. Let me just bring this side. We will say 1/4. N is the number of elements. There were 9 students, as you can see. So where there is n, I shall put 9 there. So I'll start on my calculator. I'll simply say 9 plus 1 gives me 10. 10 multiplied by the 1 there on top of 1 over 4. It will still be 10, and then divide by 4. 10 divided by 4. It gives me 2.5. So is the 2.5 value. Okay. 2.5 value. 2.5 is between 2 and 3. This is the first value, the 50. Then 71 is the second value. So 2.5 is between 71 and 73 here, because I'm counting like this in order: 1, 2, 3, like that. So the 2.5 value is in between 71 and 73. So I have those two numbers because it's 2.5, 71 and 73. Then I'll divide these by 2 to get a number which is supposed to be there, which is, this will give me 71 plus 73 gives me 144 divided by 2, 72. So the first quartile is 72. So all you know, when we calculate using this formula, what we get is the position. So the 2.5 is not the first quartile itself. No. It's not the first quartile. To get the first quartile, we need to find the 2.5 position. 2.5 position, we have to, this one, we have to look at the first position, which is 50, the second position, which is 71. So it's 0, 1, 3 here. So 0, that's the first position. 1 is the second position, and this is the third position. Now we say it's between, it's 2.5, meaning it's between the second and the third position. So it's 71 and 73. Divide by 2 to give us 72. We can get the second quartile, or what is known as the median. We can get the second quartile, or what is known as the median. We can get the second quartile, or what is known as the median. So I'll change there. I'll put 2 over 4. Two over 4 n plus 1. Now 2 over 4, it's as good as 1 over 2. So 2 into 2 is 1, 2 into 4 is 2. So the formula is reduced to that. Okay? So 1 over 2. Okay? And then here it will be like that, yes? So now I'm calculating this time around. 1 plus 9 in the brackets, that would be 10. 10 divided by, okay, 10 multiplied by 1. Still remains 10, divide by 2. It will give me 5. So the second quartile, which is the median, is the fifth value. So now I'll go to my data there on the stem and leaf and check the fifth value. The first value is 0. The second value is 1. The third value is 3. The fourth value is 6. The fifth value is 9. So this 9 represents 79. So my second quartile or median is, actually 79. So I'll come there and say 79. And then I'll come to calculate the last quarter, which is Q3. Quartile 3. Quartile 3 is given by 3 over 4. Three over 4. 3 over 4. And what I'll do here is the same thing that we've been doing. So 3 over 4, quartile 3. It is 2, the number of elements is 2, 9. So we have 1 plus 9, which is 10. Okay, 10 multiplied by 3, which is on top of 3 over 4. That gives us the 30. 30 divided by 4, we have 7.5. We have 7.5. So 7.5 value. 7.5 value is our quartile 3. 7.5 value is our quartile 3. So I need to find 7.5. So I'll start there. This is 1, 2, 3, 4, 5, 6, 7. So the seventh value is actually 81. And if we are saying 7.5 is between the 7th and the 80th value, we'll pick 81 and 85. We'll pick 81 and 85. So I'm picking 81 and 85. So I'll say 81 plus 85 divided by 2. We'll have 83. So 83 is our third quarter. Our third quarter. Quickly, let's do the extreme values. The extreme values, we have what is known as the maximum value, or let me say the upper fence. I love calling them like that. The upper fence. The upper fence is given by the formula of saying Q3. Since we want this to be big, so we want it to be the upper fence, we'll do Q3. Instead of subtracting, we'll add because we want it to be big. Q3 plus 1.5 multiplied by interquartile range. Interquartile range is given by Q3 minus Q1. Q3 minus Q1. So our Q3 is 83 plus 1.5 okay. Q3 in this case is 83, and then the Q1 was 72. So the upper value will be given by, if I go on my calculator, I can say 83. Yeah, I can load everything on the calculator at the same time. There's no problem. 83 plus 1.5, open brackets, 83 minus 72. The calculator will follow BODMAS itself. 99.5. So 99.5 is my upper fence. And I can get my lower fence now. I can do my lower fence. My lower fence is Q1. Instead of saying plus there, I'll say minus because I want it to be small. And then 1.5 multiplied by interquartile range, which is the Q3 minus Q1. So my Q1 is 72. 1.5 is part of the formula, but this time around I'm saying minus. And then the interquartile range will still remain, which is Q3 minus Q1. So I can find my lower fence now by simply saying 83, no, open bracket, 72 minus 1.5, open brackets, 83 minus 72. I have 55.5. That is my lower fence. Then I'm done with the question as per requirement, but sometimes the examiner can ask you whether there are outliers in this data or not. So let's check if there are outliers. Outliers. Are there outliers in the data? Is there a number which is lower than the lower fence? Let's check. Yes, the lower fence is 55.5. So there is a number which is below the lower fence, which is a 50 here. So the 50 shall be called an outlier. Let's see again if there is any number which is above 99.5 in our data set. The highest number is 89. As you can see, so the only outlier that we have is 50. There's no number which is above 99.5. Thank you very much. Join me in more tutorials.